everyone, welcome back to my channel. So today we're going to discuss about one of the iterative polynomial function techniques, which is the Graeffe's root squaring method. So first, let us define what is Graeffe's method. So it is a root finding method which was among the most popular methods for finding roots of univariate polynomials in the 19th and 20th centuries. It was invented independently by Graeffe, Dandelin, and Lobachevsky. Graeffe's method has a number of drawbacks, among which are that its usual formulation leads to exponents exceeding the maximum allowed by floating point arithmetic, and also that it can map well-conditioned polynomials into ill-conditioned ones. The method proceeds by multiplying a polynomial f of x by f of negative x and noting that f of x is equal to x minus a sub 1 times x minus a sub 2 and so on and so forth until x minus a sub n. While f of negative x is equal to negative 1 raised to n multiplied by x plus a sub 1 times x plus a sub 2 and so on and so forth until x plus a sub n. So the result of this multiplication is of course negative 1 raised to n multiplied by x squared minus a sub 1 squared times x squared minus a sub 2 squared until x squared minus a sub n squared. So if we repeat this multiplication b number of times, then we can write this in the form y raised to n plus b sub 1 y raised to n minus 1 plus so on and so forth until b sub n is equal to 0, where y is equal to x raised to 2b. Since the coefficients are given by Vieta's formula, we can say that b sub 1 is equal to negative multiplied by y sub 1 plus y sub 2 and so on and so forth until y sub n. Our b sub 2 is therefore y sub 1 y sub 2 plus y sub 1 times y sub 3 so on and so forth until y sub n minus 1 times y sub n. Our b sub 3 is equal to negative 1 raised to n times y sub 1 y sub 2 until y sub n. And since the squaring procedure has separated the roots, the first term is larger than the rest. Therefore, we can have b sub 1 equal to negative y sub 1. Our b sub 2 is equal to y1 multiplied by y sub 2. And our b sub n is equal to negative 1 raised to n multiplied by y sub 1, y sub 2 up to y sub n, giving the values of y sub 1 equal to negative b sub 1. Our y sub 2 is equal to negative b sub 2 over b sub 1, and y sub n is equal to negative b sub n over b sub n minus 1. So if we will look or solve for the original roots, we can have a sub 1, a sub 2, a sub 3. Our a sub 1 is equal to the 2v root of negative b sub 1, then 2v root of negative b sub 2 over b sub 1, and our a sub 3 is equal to 2v root of negative b sub n over b sub n minus 1. However, this formula, since we have negative in the inside of the radical sign, sometimes it is subjected to error. So in this video, I will show you how to use this formula, and instead of using the negative here, we will use the absolute value of the b1, b2, b3, and the coefficients. Okay, so this method works especially well if all roots are real. So for example, let us solve for the roots of the equation x cubed minus 6x squared plus 5x plus 12 is equal to 0. Now let's begin our solution by separating this equation into two parts, the left side and the right side. Okay, so first I will separate the x cubed plus 5x the left side, then the 6x squared minus 12 on the right side. Then I will factor out the x. So I will have x squared plus 5 here, and I can factor the 6 on the right side, so I can have 6 times x squared minus 2. Now, the next step, we have to square both sides of the equation. So, we will have x squared times x squared plus 5 squared equal to 6 squared multiplied by x squared minus 2 squared. Okay? Then, let us assume a value. Let y is equal to x squared. Then, we'll have to substitute this value on this equation. So, this will be y times y plus 5 squared is equal to 36 multiplied by y minus 2 squared. Now, let us expand this equation. Okay, so we'll have y times y squared plus 10y plus 25 equal to 36 times y squared minus 4y plus 4. Distribute, we'll have y cubed plus 10y squared plus 25y equal to 36y squared minus 144y plus 144. Then, let us combine the similar terms. So, this will be y cubed, 10y squared minus 36. So, this will be 26y squared. Then, 25y plus 144. So, this will be 169y. And minus 144 equal to 0. Okay? So, again, we will repeat the same process as what we did on this part. Okay? So, we will separate this equation into two parts, the left part and the right part. Okay? So, we'll have y cubed minus 169. Let's delete. Ayan. So, y cubed plus 169y is equal to 26y squared plus 144. Then, I will factor out again the y. So, I will have y times y squared plus 169 equal to 26y squared plus 144. Then, I will square both sides. So, I will have y squared times y squared plus 169 squared equal to 26y squared plus 144 squared. Then, I will repeat this process. So, I will set a value again. This time, I will let z equal to y squared. So, substitute this in this equation. We will have z times z plus 169 squared equal to 26z plus 144 squared. Okay, so since this page is already full, I will use the other page. Okay, so let us continue where we have on the previous page. So, I will write here the equation z multiplied by z plus 169 squared equal to 26z plus 144 squared. Now, let us distribute and expand this both side of the equation. So, I will have z times z squared plus 169 times 2 is 338. Z plus 169 squared is 28561. Then, on the right side, 26 squared is 676 z squared plus 7,488 z. And 144 squared is 20,736. Now, distribute the z on the left side. I will have z cubed plus 338z squared plus 28,561 z. Then I will just rewrite the right side. Ayan. Then, let us simplify the equation. So, after simplifying, we will have z cubed. 338 minus 676 is negative 338 z squared plus 21,073 z minus, so I will just transpose the 20,000 equal to 0. Then after this, we will go back to the first process. So I will separate again z cubed and the 21,073z. Then on the right side, I will have 338 z squared plus 20,736. Then I will factor out the z again, so that I will have z squared plus 21,073. Then I will just copy this one. Then next step is square. So I will square both sides. Z squared plus 21,073 quantity squared. Then 338z squared plus 20,736 squared. Then let w is equal to z squared. Then substitute this in our equation. So this process you can repeat 3 to 5 times or more. So it depends on you. So later I will tell you the difference of the answer if you will just stop on the third iteration or if you will stop on the fourth or in the fifth. So what will be the difference? Forgot to replace this one. So this will be w. Now let us distribute or expand. So this will be w squared plus, what is 21,073 times 2? That will be 42,146 w plus the square of this one. That will be 444071329. So the number will be very long. Then on the right side, 338 square will be 114,244 w squared plus 338 times 20,736 times 2. That would be 1401,736 w plus the square of 20,736 is 4299,81696. Okay, then I will distribute the w. So I will have w cubed 42146 w squared plus 444071329 w. Then just rewrite the right side of the equation. Four two nine nine 81696. Okay. Then let's simplify. We will have w cubed minus 72098 w squared plus 4300 53793 W minus 429981696 equal to 0. Now, this is the third, right? This is the third iteration that we have repeated. So, I think we can stop. So, let's try to solve for the values of the roots of this equation. So, to find the values of the roots, let's say that is a sub 1, and the absolute value of the coefficient of the W squared, that is negative 72098. Okay, the absolute value of this will be raised to 1 over 8. So, remember a while ago, we have 2v root of negative b sub 1. Okay, so this is the b sub 1, b sub 2, and the b sub 3. Okay, and since the negative sign inside the radical sign can have an error, so I decided to have it in the absolute value. So, 1 over 8, because we have repeated the process 3 times, and 2 raised to 3 is equal to 8. Now, if you have repeated the process 5 times, so you will have 2 raised to 5. So, this will be 1 over 32. Okay? So, a sub 1. So, 8th root of negative 72,098. That is equal to 4.047999. Our a sub 2, that would be b sub 2 over b sub 1. So, that is 43,0053793 over 72,098 raised to 1 over 8. So, that will be equal to 2.96449. And our a sub 3 is b sub 3 over b sub 2. Okay, so this is b sub 1, b sub 2, b sub 3. So, that would be negative 4,299,81696 over 430053793 raised to 1 over 8. And that is equal to 0.999979. Okay? So, as you can see, our a sub 1 can be approximated into 4. Our a sub 2 can be approximated into 3. And our a sub 3 can be approximated equal to 1. But we are not sure if this is positive or negative. Because in this process, we can only have a positive answer. No? So, to check whether the values that we got is positive or negative, the original roots, so you can substitute the values that we got in the original equation. So, our original equation is x cubed. I will use another color. So, x cubed minus 6x squared plus 5x plus 12. So, we will substitute these values. We will substitute 4 and negative 4. We will substitute 3 and negative 3 in the values of x. And we will substitute 1 and negative 1. So, the values that will satisfy the equation, okay, that will equate this equation into 0 is the original root. Okay, you can check by yourselves. Try substituting 4 and negative 4 in the equation. Okay, so the answer will be our final roots, or positive 4, positive 3, and negative 1. Oops. So, since we're done with numerical analysis of the Graeffe's method, let me show you the tabulated format of how we solve the roots of the equation using Graeffe's method. So I have here a table with the labels of the column are m, 2 raised to m, a sub 0, a sub 1, a sub 2, and a sub 3. So these are the coefficients of our equation. Let's start with 0. So 2 raised to 0 is 1. And our original equation a while ago is x cubed minus 6x squared plus 5x plus 12. So I will write the coefficients 1, negative 6, 5, and 12. So next step is the square of these coefficients. Square of negative 6 is 36. This will be 25, and this will be 144. The next step is 2v. So I labeled it or named it as 2v because this involves a v-shaped multiplication, then times 2. So 1 times 5 times 2 is 10. Then we have negative 6 times 12 times 2. We have negative 144. Next, we'll have 2v minus s squared for the a sub 1 and a sub 3. But for a sub 2, so it's the opposite, we'll have s squared minus 2v. So, for a sub 1, we have 10 minus 36. That is equal to negative 26. Then, for a sub 2, so reverse, I will have 25 minus negative 144. That is 169. For a sub 3, since it has no value here, so that is 0 minus 144. So that is negative 144. Then we will just repeat the process. So this time, this is the first iteration since all the coefficients are complete. That is 2 raised to 1. Then squaring again. So square, we have 676, 28561, 2736. Then 2b, so 1 times 169, 3 times 2 is 338. Negative 26 times negative 144 times 2, we have 7,488. Then, on the second iteration, that's 2 raised to 2 equal to 4. So, we have to subtract. So, 338 minus 676, that is negative 338. Then, for this one, we have 28,561 minus 7,488 is 21,073. For this one, since it's 0, so 0 minus 20,736, we have negative. Then, repeating the same process, so squaring, and then 2v again, so 1 times 21,073 times 2. Then, negative 338 times negative 20,736 times 2. Then, for the third iteration, so here we go. I'll just... So, as you can see, the numbers are getting long. And 2v, so this is e exponent s raised to 13. Fourth iteration. So, you can repeat the same process over and over again until you're satisfied. So, a while ago, we stopped the calculation of third iteration. That's why we got this equation. But this time, let us continue until the fifth, 2v. And then, lastly, I have this equation. the values that we got from the third and the fifth iteration. So the third iteration is what we did a while ago in the numerical analysis. Then, what will be the difference in the values of x for the fifth iteration? So I made a tabulated form here. This is m is equal to 3, and the values of x that we got. Okay, this is 4.0479999053 in compared with the value that we got from the fifth iteration. We have 4.0000125556. So as you can see, the values here are much better than the values that we got from the third iteration. Okay, and as I've said a while ago, if you want to know the sign, okay, if it is positive or negative for 2 and 1, let us just substitute the values in the equation. So these are the values of y. So you can see the values of y for the positive 4 is approximately equal to 0. This one, negative 1, value of y is equal to 0. Therefore, our roots are positive 4, positive 3, and negative 1. So that is how we do Graeffe's root squaring method. Okay, so if you have any questions regarding this topic, feel free to put your comments in the comment section, and you can also share this video to your friends or your classmates. Okay, so hope you have learned a lot from this topic. Thank you for watching.